Hello and welcome to this channel, and I will share you my seminar topic which I have given uh, in my first year PG in Sundargarh Government College. And here the topic name: Advance and Opportunity of Ionic Liquid as Green Solvent. Here is me, Prabhas Parikh, and it was suggested by Dr. Lopamudra Giri, who has done postdoc in Wuhan, China, and it was guided by Supradeep ma'am. So let's start. Here is my content page: introduction, features of ionic liquids, history, structure of ionic liquid, why they are liquids, synthesis, applications. And here is the introduction part. As the ionic substances are in solid form, so here is the main key is it is in the form of liquid. So ionic substance exists in liquid phase whose temperature is below 100 degrees centigrade. Okay, it is a non-aqueous ionic solvent. It is also a green solvent. Okay, so as it has many key features, so we can make and we can also use in our industrial process or many cases. Okay, it's also called as ionic fluid, molten salt, liquid organic salt, fused salt, neutral salts. And here the key features of the ionic liquids. These are basically non-volatile and negligible vapor pressures, noble class of molten salt composed of ions. Many things are there, and these are easily separable. Hydrophobic and hydrophilic, so both characters, etc., are the key features of the ionic liquids. Why I choose this? Because now day by day the publications are rapidly increases of it. For you can see easily. Next, is here I come to history. There's the history part. It was invented by Paul Walden in 1914, and the first the ionic liquid is ethyl ammonium nitrate, whose melting point is in 12 degrees centigrade. He combined both ethylamine and concentrate nitric acid. He found the ethyl ammonium nitrate with this is the compound. Next I comes to solvent. Solvent which things we call the solvent, which dissolve solute and form the solution. Okay, and they can begin or hazardous and have implication for consumer environment, etc. Basically I made it for you for presenting in your seminar. Okay, and you have to explain about it, and you have to see many videos and many theory you also have to read for your doubt clearance. And you can also ask me question in the comment section. Okay, so why is worry about solvent selection, and what the key things to select solvent? These are the because solvent are the critical participants promoting chemistry, that is SN1, SN2, etc. All many reactions are done through the solvent, and these dissolve the reactants, and it helps and it make factors affecting in pH, etc. And many bonding are there also. Next, solvent selection guide. We have to choose its polarity and functional group, temperature, pressure, etc. Many things are there. And there's the green chemistry. Green chemistry is the design of the chemical product and process that reduce or eliminate the use of or generation of hazardous substance. And the green chemistry work as follows: the pollution prevention, atom economy, less hazardous chemical synthesis, designing safer chemicals, energy efficiency design, renewable food stocks, uses, catalysis, degradation design. This is your green chemistry part, and I have simply pasted here also. And here is the basic information about ionic liquid, and you can see its naming also easy, that 1-butyl 3-methyl imidazolium, that is from butyl B, and from methyl M, and from imidazolium, that is IM, and the hexafluorophosphate, that is PF6. Okay, so it's quite easy to make naming of the ionic liquids. Next I come to structure of the ionic liquid. As it is ionic, so it contains cation and anion, and the anions are, and the cations basically these are in bulky shape, and asymmetric organic cations are used in the cationic part. You can see the pyridinium cation, dialkyl imidazolium, and alkyl pyrrolidinium, etc. are here. And the anion depends on the ratio ionic liquid, water, system temperature, alkyl chain length in the cation. So by choosing cation we can modify our anion also. You can see here the water immiscible and water miscible. It's of whatever we will use it. So we have to choose whether it is hydrophobic or hydrophilic. That is PF6 minus is water immiscible, that is hydrophobic, and CH3CO2 minus is a hydrophilic character. So main thing are there. We have to use this in our cation by choosing what we will use for it. Then ionicity of the ionic liquid. Basically low acidity or low basicity or low pH range chemicals are used for the formation of ionic liquids. So you can see here, you can also analyze also. Here the name of the ionic liquid, as I have previously said that the naming is quite easy to write, and you can please check this. What is the difference between ionic salt and ionic liquids? The salt is in crystal form, the liquid is in liquid form, and the gap are somewhat tight in our ionic salt, and it's loose in ionic liquids. So these are in liquid form, these are in solid form. Basically its melting point is ionic salt melting point is 801 degree centigrade, but the melting point of ionic liquid is in between below 100 degree centigrade is of course. Next, why they are liquids? Because one is great bigger size, and another is the ion cation are bigger size and another small size, so there is a weak interaction of ions occur. So and these are in there is the weak covalent bond or weak van der Waals forces are there, for which they make liquid. They are in the form of liquids. And you can see here how the structure of NaCl and our ionic liquid are there, and you can analyze why it is in the liquid form. Next here the comparison of organic solvent with ionic liquid. Okay, because we use in our industry organic solvent, or we can use ionic liquid. Okay, by comparing this we can easily understand that ionic liquid is more useful in our industry or any chemical laboratory also for as a solvent. And here the synthesis of ionic liquid. You can see that the company BASF, CTEC, Fulka, Mark, Lolitech, and many companies are there which form ionic liquids, and most of the ionic liquid are expensive, so and cost can be reduced by synthesizing in laboratory also. Okay, and if we will buy the ingredient of it, then we can reduce it 10 times of the original cost. And here the method of preparation are there. There is the metathesis process and acid-base neutralization, direct combination. Synthesis of a liquid. And there are the two steps, that is quantitative. There the in previous one you can see metathesis, acid-base neutralization, direct combination. In first step that we will combine, that is the quaternization step. In quaternization step, just remove the Cl and join with H, that is the ion form, and after that, in first case you also get the any liquid, in second case also you get the any liquid, but in the form of that cation and anions, you can see here. And here the laboratory synthesis. Let's have
Mix
a look.
aluminum chloride and urea. These are both solid, but when mixed, aluminum chloride complexes with urea to form ionic compound. In the beginning, the mixture gets too hot,
Let's see,
but in the end, it should be
any
heated.
liquid will form.
The molten salt obtained is a viscous liquid, typically yellowish or brown. However, this ionic liquid reacts with air moisture, so the trick is that it should be prepared in an inert gas glove box. Most common cations are based on alkyl ammonium salts, such as amine cation. When mixing amine chloride with aluminum chloride, first we have formation of tetrachloroaluminate. When excess of aluminum chloride is added, heptachloride.
Okay, in this way that our ionic liquid will form, you can see in the screen.
Mix aluminum.
And here the instruments are used for the formation of ionic liquids. That is the refractometer, tensiometer, density and viscometer, conductivity meter, and coefficient titrator. And here how it affects in the reaction. You can see the in the diol-solvent reaction, it is endoselectivity and highly polar in solvent, increases the reaction rate, allow water sensitivity reagent to be used. Simple workup. It is a simple workup process. Okay, we have not to use many phases, or we have not to go through the many steps. The ionic liquid can be reused. Okay, that's the key features of our ionic liquid, that it can be reused. So it's a good process, and you can analyze that in the time. Here the time are same, 72 22 72 22. In this way, this you can see that the 91% yield is showing here, that is from BM, IM, BF6, BF4. Okay, you can easily compare in which case we will get more result. Next is the hydrogenation reaction. Okay, next is your reduction process, and here is the application. It is used in chemical processing, cellulose processing, engineering fluids, electrolyte, functional liquids. In many cases that ionic liquid are used. And here you can see the year and how we will use in which types, in which case, and in which way we use ionic liquid as things. Okay, where we will use as electrolyte, solvent, or mobilize a liquid, or internal, or many things are there. And here the industrial process of ionic liquids. There is a company, and there is the process where through they form ionic liquid, and the ionic liquid is which type of, and what are the types they use or they form ionic liquid. And the scale is there. You can say pilot, commercial, etc. are there, because they use for it, whether they are made for their use or for commercial purpose, for sell that things. And here also you can see the starter, that is it even used for R&D sector or pilot or commercialized. Here you can say it is also in process and technology, functional fluids, synthesis and catalysis, thermodynamic applications, chemical applications, analytics. Here I will suggest you one thing that our ma'am asked me about the point included here, all the things. So you have to just search in your Google or anything, and be clear about these points are there. Okay, so hope you understand all the things. You hear my reference, and I have seen many YouTube videos also, and so many things. In this section I will say you have to remember, or you have to know what you present in your seminar. Okay, what you have written in the in your screen, for which you can easily define in front of your teachers or ma'am or sir. Okay, so thank you, and here is my presentation, and the picture was taken by my friend, and the presentation the date, that is 23/4/2022. So here is my presentation. Thank you all of you. Thank you for listening, and thank you for watching this video. Thank you. And if any question arises, then comment me or ask me freely. We will discuss about it. And thank you.